Example 6.6 or 7.6 for the given textbooks. For details, please see the description below. A Carnot refrigerator cycle is executed in a closed system in a saturated liquid vapor region using 0.8 kilograms of refrigerant 134A as the working fluid. The maximum and the minimum temperature in the cycle are 20 Celsius and -8 Celsius respectively. It is known that the refrigerant is saturated liquid at the end of each heat rejection process, and the net work input of the cycle is 15 kilojoules. We need to determine the fraction of the mass of the refrigerant that vaporizes during the heat addition process, as well as the pressure at the end of the heat rejection process. The first step in this problem is to evaluate the coefficient of performance for the refrigerator using temperatures. So the coefficient of performance for the refrigerator is simply going to be 1 over TH over TL minus 1. And then remember to use all the temperatures in absolute values. So we have the value of TH is equal to 20 Celsius, so it's 20 plus 273. The value of TL is -8. And once again, we have to add the 273 to make it into Kelvin, minus 1. And if we calculate this, we find that the coefficient of performance for the refrigerator is equal to 9.464. Now that we have the value of the coefficient of performance, we could find the amount of coolant. That is going to be done by evaluating QL and taking the value of the coefficient of performance of the refrigerator times the amount of work going into the refrigerator. So we take 9.464 and we multiply it by the value of 15 kilojoules, and that tells us that the value of QL is equal to 142 kilojoules. QL, or the amount of cooling, could also be related to the amount of energy that is required for the vaporization process that takes place inside of the refrigerator. Therefore, we could say that QL is simply the mass that it vaporizes times the amount of enthalpy of vaporization, which is equal to HFG at the low temperature. In order to do that, we go to the table A11 for the refrigerant, and the low temperature is -8, and we see the value for enthalpy of vaporization is equal to 204.59 kilojoules per kilogram. And then we have the value of QL. Therefore, we now could solve for the mass of evaporization. So we could simply say that that's the amount of QL divided by HFG, and then we calculated 142 kilojoules, and from the table we found it to be 204.59 kilojoules per kilogram, and we find that the mass of vaporization is equal to 0.694 kilograms. Now, in order to calculate the fraction of the mass of the refrigerant that vaporizes, we simply do the mass fraction. Is simply going to be the mass that we just calculated, whatever gets evaporated, divided by the total mass that we had. So this is going to give us 0.694 kilograms, and we divide it by the total mass, which is equal to 0.8 kilograms, and the value that we get is 0.868 or 86.8%. That value indicates what is the value or the percentage of the mass that is converted in the vaporization process. The last step is to determine the pressure at the end of the heat rejection process. That is simply the saturated pressure at the rejection temperature. In that case, we go to table A11. The rejection temperature is going to be 20 Celsius, and we see the saturation pressure is equal to 572.07 kilopascals. That is the value of P4 in this process.